Dear students, today we'll see transistor characteristics in common emitter configuration. Now when we say common emitter configuration, then the emitter terminal of the transistor will be made common for the input and output circuit. So here you can see this is the NPN transistor, this is the emitter base collector. Emitter is made common to both input circuit and output circuit. So this you can take it as input circuit, this you can take it as output circuit. Okay, so the input is given between base and emitter, okay, and the output is taken across collector and emitter, okay. Now here to study the characteristics of input and output between voltage and current, first we should see what is our input and what is our output. Okay. Now here if you see, this is the circuit where the input current is IB, and because this is a NPN transistor, this is NPN transistor, P type of base is connected to positive of the battery and N type of emitter is connected to negative of battery. That means this junction between base and emitter is forward biased. This junction is forward biased. Okay. Similarly, if you see the other junction in the output circuit, the collector is N-type semiconductor. It is connected to positive of a battery, and emitter is N-type semiconductor. It is connected to negative of a battery. Okay. So here, if you see this positive and negative, you can see that this is reverse biased. This is reverse biased. Okay. Now here, to plot the input characteristics, we have to note down input current and input voltage. Input current which is flowing in the base and input voltage across base and emitter by keeping the output voltage constant. So here you can see this is a graph. This is a graph of input current and input voltage. So this is input current IB, which you are going to read here, and this is the input voltage VBE, which you are going to read. Okay, and this is what we have told constant. So this is going to remain constant. VC is going to remain constant. Now say initially if you keep VCE as 1 volt, this you just adjust and keep this as 1 volt, and now don't disturb it. Now in steps of 0.4, 0.8, 1.2, you go on varying this voltage, and for that corresponding voltage you note down the corresponding current. Then you will get this type of curve. Okay. Now this type of curve shows something like forward bias in a PN junction diode. So here you can see the knee voltage. Initially the current is 0. After the knee voltage is crossed, the current will increase as the little voltage is increased. So little voltage is increased, but the current is increasing very fast. Okay. Similarly now, if you change the value of VCE, if you change it to 10 volts, same type of curve you will see, but it will go little behind, like this. Same type of curve, but it will go little behind. So if this was kept at 1 volt, this was the curve, and same procedure if you repeat for VC is equal to 10 volt, this will be the curve. Okay, so as you increase the VC, the curve will go on little farther, but it will be the same type of curve. Now here what we are seeing is, as the input voltage goes beyond the knee voltage, the current increases more, the forward current increases more. That is IB current increases more. So it is a graph between input current IB, input voltage VBE for constant output voltage VCE. Okay, this is the input characteristics. These are the input characteristics. Now here, if you want to find the input R resistance, then you have to see change in input voltage upon change in input current. This will be the input resistance at constant VCE. So change in input voltage to the change in input current, the ratio of that will give you the input resistance. Similarly, if you want to note down the output characteristics, The output characteristics will be a graph between output voltage. Output voltage is, this is the output circuit. This is the output voltage VCE, and output current. Output current is IC. So that current you are going to see here, and this voltage you are going to see here. For constant input current, that means this voltage you have to keep it constant, the current you have to keep it constant at some value, and then go on changing this voltage. Note down this voltage and this current, this voltage and this, as you change in steps this voltage, that is the output voltage VCC. Okay. Now here if you see, the x-axis is the output voltage and y-axis is the output current. This is VCE. Whatever you are going to read here in this is VCE, and this is IC, whatever you are going to read in this milliammeter. Okay. Now as you change VCC will change in steps of 2, 4, 6, 8, 10, 12, and similarly you can note down the readings of IC, that is the output current. Okay. Now here if you see the first curve, second curve, third curve, fourth curve, fifth curve, as you increase the voltage, output voltage, the current will initially increase, but later on it remains constant. Current will initially increase, but it will remain constant. Current will initially increase, but it remains constant. That means the output current is not depending on output voltage. The output current is depending upon the input current. So here you can see, if the input current IB is made 0, then output current also is there. Now if you increase the IB, output current also is increasing. So again you increase IB, output current also is increasing. Again you increase IB, output current is also increasing. That means output current is depending on input current and not on output voltage. Okay, this is one thing. And whenever there is no input current, but still you will get some output current because of leakage current, because of minority current. So that will be area called as cutoff region. And initially as you change the voltage, the current rises, that area is called as saturation region. Saturation and cutoff regions are used for turning on and off the transistor, which we use in industrial applications. Similarly, the operation in between, when there is some value of IB, that is input current, the constant collector current, this will be showing you active region. Active region is very important for a transistor to be used as an amplifier, which is an important application of a transistor. So these are your input and output characteristics in common emitter configuration of a BJT.